Swayam Prabha. Digital India. Educated India.
Hello everyone. Now our next topic is twist. So twist here we'll discuss and its analytical approaches, and it's a yarn twist. Okay. So what is twist and why do you want this twist? So if you see, the twist is the spiral turns given to the yarn in order to hold the fibers or threads together. Now, twist is not only given to the yarns but in the roving also. Okay, and this twist we can have two types of twist. One twist is called the real twist, where this is the fiber strand. In one side there will not be any rotational motion, but in other side there will be rotational motion. So this is called real twist. In another situation where this where there is no rotation here in real twist, there may be some linear motion also, the linear motion but no rotational motion. So this may or may not have linear motion, but there won't be any rotational motion. And on the other hand, second one is the false twist. In false twist, either of this ends or both the ends, there is no rotational motion. They may be either fixed or there may be linear motion. Suppose here the this yarn is winding, so there may be linear motion, but there won't be any rotational motion in these two ends. But here at the center there will be, and at not only center, in between these two end point A and B, there will be a rotation. This is called false twist. So if you are rotating at the end, so there will be a twist in a particular direction depending on the direction where it is rotating. So this is rotating, so this may rotate clockwise or maybe anti-clockwise. But in case of false twist, this is the point where the rotation is taking place, a midpoint, it's a C. So right side of the C there will be a particular direction of twist, but on the other side, left side, there will be in other direction, but the level of twist will be same in both the directions. Now when the strand is, or say yarn is moving in particular direction, it's winding here taking place. So this rotation at the middle is continuing, and suppose this is positive side and this is negative side of twist of same extent, and while moving linear movement, when as soon as it's crossing the left side of this part zone, when it's crossing the point C, rotational point, the negative twist present in this strand left side will be superimposed on the positive twist in the right side, and finally this will get cancelled, and finally we will get a strand without any twist. And for different applications we use this false twist method. One very common example is that it's called false twist texturing. And in case of real twist, when it is winding and at the same time if we are we are twisting, at the same time if we are winding here, there will be a real twist imparted on it. And example is that ring spun yarn and in roving frame twisted by the flyer. So if I draw the say roving frame, these are the drafting rollers, and after drafting here this is the flyer and the drafted strand is coming. So rotation of flyer imparts the real twist in this strand, and the other end, in the other end, this end there is no rotational motion, only linear delivery is taking place. That's why this twist is termed as a real twist. So the twist is imparted on the fiber strand to give strength and hold the fibers together. Suppose this is a sliver where these fibers can simply come out because there is no lateral force, and when we apply twist, there will be a friction generated within the strand between the fibers, and which will hold the constituent fibers together. Okay. So primarily this is imparted on the staple yarn, okay, which gives the strength in the yarn. Also we impart twist in the filaments. So staple yarn, definitely we need twist to hold the fibers together and to impart strength on it. But in case of filament yarn also, although strength will not get affected. Without twist we can also get strength, but during the processing the filament can get separated. So this filament can get separated. To hold the filaments together in the multi-filament, we impart small quantity of twist. So if you see the twist is basically of two types. Broadly we can divide the twist into two types. One is called Z twist, another is S twist. So depending on the direction of the fiber alignment on the yarn surface, we classify the twist. So Z twist means this, if you imagine the fibers are forming a Z shape, and here fiber is forming an S shape. So this direction here, or here in this direction, is the fibers from where we are observing. So as I have mentioned, false twist is used in the texture yarn. There are other places we will discuss where false twist is imparted, like in roving production at the flare top portion the false twist is imparted. So S twist and Z twist we have discussed. First let us try to understand what are the effects of twist. Twist increases the lateral force. While twisting, the lateral force increasing, which actually increases the fiber to fiber friction, and yarn strength increases. So when the lateral force increases, so more and more fibers come together and contribute towards the yarn strength. Like in case of this sliver, if you see there is no twist. When we apply any force, tensile force, the fibers simply come out. Because of the absence of the lateral force, the fibers are coming out. So when we apply the twist, what happens here? Suppose this is the fibers, these are the fibers without any twist. Okay, so length of the fiber at the surface and at the core are same. But when we apply twist, the surface fiber will have to travel longer path. As the length available is same and they are trying to travel longer path, so this outer fibers present in the outer layer will exert inward force to the core fibers, which will result the lateral force. So as the twist increases, the angle that the fiber makes, a particular fiber makes with the yarn axis, increases. So the contribution to the fiber strength towards the yarn strength decreases. So what does it mean? In case of fibers are parallel, the angle of the fiber towards with the axis is 0 degree. This is the angle, and the contribution of this particular fiber at the center or any fiber towards the, it will be actually contributing 100% to the yarn strength. But when the fibers are twisted, so this fiber, suppose this fiber is having strength of S, individual fiber, Si, and there are say 100 fibers are there. So yarn strength will be typically 100 multiplied by Si, addition of individual fiber strength. On the other hand, if the fibers are of certain angle, it's twisted at in certain angle, say theta, the fiber strength Si will not be completely contributing towards the yarn strength. Instead, what it will do, a component of the fiber strength will be utilized. So what is the component? Cos theta component, Si cos theta. When cos theta is 0, so it will be 1. So 100% contribution will be there. So for 100 fibers, 100 Si cos theta. If assuming all the fibers are aligned in the same angle. So as we go on increasing the twist angle, so the contribution will be reducing gradually. So if we see, if we try to plot twist versus strength, due to fast impact, where with the increase in twist, the lateral force increases and binding force increases, so it contributes towards the increase in strength. So frictional force increases, so this is increasing. But after certain time, there will be further increase in the strength with the increase in twist, because that it has reached its optimum point where fiber sliding is not possible, strong, completely locked. But due to this angle of twist, as the twist increases, the angle increases, so this twist value will, strength value will decrease. This is called obliquity effect. It means as the angle increases, strength decreases. And in the staple yarn, both these two phenomena work together. So ultimately we get this type of shape for staple yarn, and for filament yarn we get constantly reducing strength, although there will be initial increase little bit due to the cohesion at the initial stage. So this is the relationship as I have discussed. So further increase at this point reduces. So this is the point where at particular twist the strength generated in the yarn is maximum. This twist is called optimum twist. Okay. This is for continuous filament. Small amount of twist is inserted to keep the filaments together. Twist increases initially and then decreases. And this increase is basically due to the averaging out of the variability of filament strength. So because of the variability of the individual filament strength, the initial effect of twist is to support the weaker filament. So that's the weaker filament will be supported, and that's why little bit increase initially. The twist has got a prominent effect on the characteristics of fabric, which is being utilized in a larger way in every application. So let us see handle of the fabric. So I want a soft handle, soft fabric. So ideally for any yarn twist, for a given option one should opt for zero twisted yarn. Zero twist means it will become very soft, absorbing, but as zero twisted staple yarn is not possible, so we have to apply certain twist. I should say zero twisted yarn is not impossible. It's possible, but normally we don't go for this type of zero twisted yarn. So as twist level increases, the yarn becomes more and more compact, and which gives harder feeling. See, if we want soft fabric, so we need lower twist. If we want higher strength, we want little bit high twist, at least within the acceptable range. So if we see the knitted fabric or undergarment which is directly touching our skin body, there we use knitted fabric typically, tight fit clothing. Knitted fabric is basically knitted fabric's characteristics is that high stressability. But when as it is touching, we need a yarn with a soft feel. So for that, low twisted yarns are used. So for knitted, used for undergarment, we use low twisted yarn. For woven fabric, particularly for work, we need a yarn which is compact. Little bit high strength is required, and compact yarn is required because the yarn has to move through the heel die and the slay. So there will be high rubbing action will be there. So we need a compact yarn so that fibers doesn't come out. But on the other hand, in weft yarn, we don't have that problem. So we can just insert the weft yarn. So if there is a variation in twist, so work yarn will be little bit high twisted and weft yarn will be low twisted. But typically we normally use in a similar type of twist level. But if we at all want to reduce the harshness, so we cannot play with the work thread. So we have to play with the twist level of weft threads. Okay. So fabrics made of high twisted yarn will therefore feel harder and will be thinner because the yarn diameter reduces with the increase in twist. Fabric produced from low twist yarn will have softer handle, and at the same time, if we apply low twist, there will be higher air pockets in the yarn or low twisted. Higher air pocket is required if we want to produce a fabric with low low thermal transmission. So for woolens, we need, for winter wear, we need fabric with low twist. As the low twisted yarn becomes soft in handle, but the problem is that it will be weaker and peeling will be more and abrasion resistance of the fabric will be poor because fibers will come out easily. So we have to optimize the twist parameter to have optimum fabric characteristics and optimum the peeling and abrasion resistance. Now coming to the moisture absorption. High twist yarn where fibers are hold very tightly and water cannot penetrate easily. On the other hand, if we use a low twisted yarn, so this will become the softer and air pockets will be there, water can penetrate easily. So this characteristics of just playing with the twist, we can increase or decrease the moisture absorption. There will be some applications where high moisture absorptions are required, like your wipes, or some other absorbent material. If you want to produce absorbent fabric, we have to impart low twist. And on the other hand, if we want to produce waterproof type fabric, there water doesn't penetrate inside, so we have to use the high twisted. So high twist yarn used where high degree of water repellency is required, like gabardine fabric. So where we use the high twisted yarn, and also in umbrella cloth. Cotton umbrella cloth is also important, where we use high twisted yarn. So in wipes, as I have discussed, we can use the low twisted yarn. Wearing properties. So abrasion and peeling, that I have already discussed. So if we want to increase the abrasion resistance or improve the peeling resistance, so we have to increase the twist length. So high level of twist resist the fibers to easily come out. Aesthetic, which is extremely important for apparel application. So aesthetic means its appearance. So by changing the twist, light reflection can be changed. Like same yarn count, one is high twisted, another is low twisted. Same fiber, same yarn count, one is high twisted and one is low twisted. If we use alternatively, we will get certain aesthetic effect. And also, so this is say 10 yarns are of high twisted. 10 yarns we are using of high twisted, and a set of 10 yarns are low twisted. We'll see a band stripe of thick and thin places, and also due to the level of twist difference, the light reflection will be different. Light will get reflected differently, and we will get aesthetic appeal. And also one can do in worsted cloth, the twist and shadow effect is very popular, where a set of thread alternate in certain threads, say 10 threads, we are using S direction twist, and then next 10 threads we are using Z direction. So these are the Z direction, these are S direction, and in this way set is prepared. So this light will get reflected in different direction depending on the twist fiber orientation. So you will get of the same yarn, same color, but so both are say black colors, but you will get clear shadow effect, clear stripe will be. This type of aesthetics we can develop by playing with the twist only. So different patterns can be generated. So we are weaving alternate bands of S and Z twist, as I have explained. Shadow stripe effect. This is very popular in worsted shooting. And level of twist can also enhance the or subdue the twill effect. A twill effect can be enhanced or subdued depending on the direction of twist. If the twist direction is same as the twill direction, then twill effect will get enhanced due to the light reflection. So jet twill fabric produced by jet twist yarn will have enhanced jet twist twill effect. So that you will get clear twill line will be visible. But if you want to reduce the twill line, then you use S twisted yarn. Cover factor and transmission characteristics. So for keeping the same thread density, same yarn linear density, if we increase the twist, the air transmission will increase, because air transmission depends on the opening between the yarn. But so, and it will reduce. So with the higher twist, if the twist increases, cover factor will reduce because of the diameter. Cover factor depends on the diameter of the yarn. As the twist increases, diameter reduces. So cover factor reduces so that openings will be there, air will pass. But as far as the liquid water transmission, the transmission depends on the capillary channel, and capillary channel, the straight capillary channel will actually enhance the speed of transmission. Two yarns with a, say ideally say there is zero twisted yarn and another is twisted yarn, a third one is very high twisted yarn. So this will have highest liquid transmission provided the diameter is same, because capillary channel diameter should be same. And here, as the twist angle increases, so the tortuosity, that liquid has to travel longer path, which will reduce the liquid transmission. Air and moisture vapor transmission, wicking, thermal transmission. So all these things affected by the twist. By changing the twist, we can control this thermal transmission characteristics. Now yarn twist application, very common examples are there. As I have mentioned, that knitted undergarment, warp weft, like georgette is one example, it consists of high twisted continuous filament yarn in both warp and web. Small crepe chiffon is also another example. Warp continuous filament yarn with high twist Z in warp and high twist left-handed twist in S direction twist in web. So Z twist in warp, S twist in web. Twist shadow effect that I have already mentioned.